Hello everyone. In this video, I will be talking about units and measurement. Introduction. This is the second chapter in the NCERT textbook for 11th class. Now, introduction. The comparison of any physical quantity with its standard unit is called measurement. So, measurement involves a comparison of a quantity with respect to a standard unit. The units for the fundamental or base quantities are called fundamental or base units. Examples of such units include meter, kilogram, second, etc. Then, the units which can be expressed as combinations of base units are called derived units. Some of the examples are velocity, acceleration, force, work, pressure, etc. The units of all these quantities are derived units, since they are expressed as combination of base units. For example, the unit of velocity is meters per second. Now, international system of units. In earlier times, scientists of different countries were using different systems of units for measurements, and a need for standardization of units arose. There were mainly three systems which were existing at that time. That is the CGS system, in which length was measured in centimeters, uh, mass was measured in grams, while time was measured in seconds. Then there was the foot-pound second system, in which foot was the unit of length, pound was the unit of mass, and second the unit of time. And then there was the MKS system, where M is meter for length, kilogram for mass, and second for time. Then in 1971, in a conference, the system of unit which is at present internationally accepted for measurement is the System International de Units, abbreviated as SI. These 7 base quantities are the base quantities in the case of SI unit. It includes length. For length, the unit is meter. The meter is the length of the path traveled by light in vacuum during a time interval of 1 by 299,792,458 of a second. Then for mass, it is kilogram. The kilogram is equal to the mass of the international prototype of the kilogram, a platinum iridium alloy cylinder kept at International Bureau of Weights and Measures at Sèvres near Paris, France. These are the standards based on which these units are defined. Then there is for time second. For the time second, the standard is the duration of 9,192,631,770 periods of the radiation corresponding to the transition between the two hyperfine levels of the ground state of the cesium-133 atom. Then for electric current, the SI unit is ampere. The ampere is that constant current which, if maintained in two straight parallel conductors of infinite length of negligible circular cross section and placed 1 meter apart in vacuum, would produce between the conductors a force equal to 2 into 10 raised to minus 7 Newton per meter of length. Then for temperature, the SI unit is Kelvin. 1 Kelvin is the fraction 1 by 273.16 of the thermodynamic temperature of the triple point of water. Then for amount of substance, the SI unit is mole. The mole is the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kilogram of carbon total. Then for luminous intensity, the SI unit is candela. CD, simple is CD. And the definition is the candela is the luminous intensity in a given direction of a source that emits monochromatic radiation of frequency 540 into 10 raised to 12 Hz, and that has a radiant intensity in the direction of 1 by 683 watt per steradian. Now, in addition to all these base units, there are two more supplementary units in the SI unit system. These are, first one is the radian, which is the unit of plane angle. 1 radian is the angle subtended at the center of a circle by an arc of length equal to radius of the circle. Then the another one is steradian, which is the unit of solid angle. 1 steradian is the solid angle subtended at the center of the sphere by its surface, whose area is equal to square of radius of the sphere. Now, we can see about the errors in measurement. What do you mean by error? Error is a uncertainty present in the result of measuring instrument. Or we can say that errors are what makes the value shown by these instruments unequal with the true value of the quantity. Now, the accuracy gives the closeness of the measured value to the actual value of the measured quantity, while the precision gives to what resolution or limit the quantity is measured. Now, there are many types of errors. First one is systematic errors. This type of errors occurs when there is a change in one direction. That is, it may be a positive change or a negative change. It can be caused due to many conditions like the experimental setup, personal errors, or certain other conditions which affect the reading. Then there are random errors. Random errors are errors which vary in size as well as range according to the certain conditions which are prevailing in the environment. Then there is the least count errors. Least count errors are the errors caused due to the least count of a instrument. Least count is the minimum resolution a instrument is able to give. If the least count of an instrument is lower, for example, in the case of a screw gauge, the least count is 0.01 meter, while in the case of a spirometer, it is 0.001 meter. Hence, the spirometer will be more accurate compared to the screw gauge, since the least count error will be lower in the case of spirometer. Now, absolute error. Absolute is the difference of the magnitude of the error value from the true value of the quantity. That is, it is the absolute value. That is, without the any sign. That is, it is the modulus. That is given by absolute error. Then there is relative error. Relative error is the ratio of the mean of absolute errors, the mean of all the readings taken by the instrument. If the relative error is expressed as a percentage, then it is called percentage error. Now, combination of errors. If we are taking many readings and using many instruments, each instrument will sometimes have its own errors, and these all errors actually add up, giving a resultant error. There are certain rules which are considered in such a situation. When two quantities are added or subtracted, the absolute error in the final result is the sum of the absolute errors in the individual quantities. Now, when two quantities are multiplied or divided, the relative error in the result is the sum of the relative errors in the multipliers. Then the third condition is the relative error in a physical quantity raised to the power k is k times the relative error in the individual quantity. So this is the end of this video. In this video, I have just given a basic introduction in about the units and measurements and also covered errors. The rest of the chapter will be discussed in the next video. If you have got any doubt in the topics discussed in this video, please comment in the section below. Thank you.